Now, in order to see where this comes from, in addition to just the schematic piece of this, we can also look at this equation up here and say, if we look at the total charge, we look at charge, it's C times delta V, okay? And since the total charge is going to be how much charge is on this capacitor plus how much charge is on this capacitor, Q total will be Q1 plus Q2. And Q1, well, that's going to be capacitor 1 times the voltage. And Q2 is going to be C2, capacitor 2 times the voltage. And if they are looking at the same voltage, which in this case, if they're in parallel, they are, right? The positive side of this battery touches this side of the capacitor. The negative side touches this side of the capacitor. So they're looking at the same voltage. Therefore, that delta V can be factored out. And I have delta V times C1 plus C2. Well, Q total is equal to total capacitance times the voltage. Again, based on this right here. So as a result, the delta V's can cancel out on each side, and you see the C total is just the sum of those two capacitors together. Now we can actually do some examples here. Let's say that what we have, say I have a 40 microfarad capacitor, a 20 microfarad capacitor, and an 80 microfarad capacitor. And let's say that my voltage is 5 volts. And I want to know how much charge can be stored here. Well, I look at this and I say the total capacitance is going to be the sum of all of these. +40 plus 20 plus 80, that looks like 140 microfarads. And the total charge that I can store is going to be delta V times C. So 140 microfarads multiplied times 5 volts. And that is 700 microcoulombs. And again, I don't always have to write this out as 10 to the minus 6. I can see that if it's microfarads and if the volts are just normal voltage, then it's going to be microcoulombs and vice versa.